It's time for the moment you've been waiting for. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Tsh, da, 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 da. Di, da, di, di, da, di, di, da, 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 da. Di, da, di, li, da, di, li, di, da. Di, da, di, li, di, da, di, li, 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 da, di, da, di, da, di, di, da. Preparing the
Periodic table.
Today we're going to be talking about periodic trends and the different types of elements on the periodic table. There are three main types of elements. There are the metals, the nonmetals, and the metalloids. To separate them on the periodic table, we draw this staircase right here. All the elements on the left side are metals, and all the elements on the right side are nonmetals, except for hydrogen. That one is considered a nonmetal. Metals can be easily, you can tell what a metal is because metals are malleable, ductile, shiny, conductive, and in most cases, except for mercury, solid. Nonmetals, however, are dull, brittle, non-conductive, and they can be solids, liquids, or gases. Metalloids, or semimetals for some people, lie along this staircase right here, and they share the properties of both metals and nonmetals. Specifically, they are boron, silicon, germanium,
Arsenic, antimony, tellurium, and polonium.
On the periodic table, we have two ways of defining the grid-like structure. We have the groups, which are the vertical columns, and we have the periods, which are the horizontal ones, the horizontal rows. Many of the groups have specific names. This group right here is called the alkali metals. This column is the alkaline earth metals. All the way over here, we have the halogens. And here we have the noble gases. Now, whole sections also will have names. So this whole little rectangle right here are called the transition metals. And this rectangle right here are the intertransition metals. Many of these groups have very similar properties, where all the elements have similar properties. The alkali metals specifically are a group of highly reactive metals, where when you put them in water, many of them will explode because they so easily lose their electrons. On the complete opposite, we have the halogens, which are incredibly electronegative, which means they attract electrons, and they like to grab them, which makes them very reactive. And this column right here are the noble gases, which are generally non-reactive and rarely will react to their elements because of the fact that they have a full valence shell of electrons. Many of the atoms in nature will bond with themselves to form what's called a diatomic atom. So, like hydrogen in nature would be H2. There are 7 different diatomic atoms, and it's pretty easy to figure out which ones they are. So, like I said, hydrogen is one of them, and then all the way over here, the rest of them form a 7. Many people find an easy way to remember all the diatomic atoms by saying, have no fear of ice cold beer. Now we're going to talk about periodic trends. The first trend we're going to talk about is electronegativity and electron affinity. These two properties are essentially an atom's ability to attract electrons to itself. Electronegativity and electron affinity grow as we go right across the periodic table. They also increase as you go up the periodic table. Excluding noble gases. This does not include the noble gases because they already have all of their electrons.
This happens because as you go right across the periodic table, there are more protons in the element, giving it a higher positive charge. A higher positive charge attracts it more to electrons. Electronegativity increases as you go up because there's a shorter atomic distance, and by Coulomb's law, it's a stronger force.
The next trend we're going to talk about is ionization energy. Ionization energy is the energy required to remove an electron from an atom's valence shell. The ionization energy increases as you go up along the periodic table. And as you go right across the periodic table.
This happens for the same reason as electronegativity, because a higher force requires more energy to strip an electron.
The next trend we're going to talk about is atomic radius. Atomic radius is basically the size of the atom. As you go down the periodic table, atomic radius increases.
This is because there are more shells of electrons.
And as we go, believe it or not, as we go left, atomic radius increases.
This is because there's a weaker force causing the electrons to be pulled in less, making the atom bigger.
The last trend we're going to talk about are metallic properties, nonmetallic properties, and reactivity. As you go left and down, metals characteristics are more prevalent. They become shinier, they become more malleable. Especially down here, you can pretty much just bend the metal any way you want and even cut it in half. But this is the opposite for nonmetals. Nonmetals define their characteristics more as you go up and right. These trends are the exact same thing for reactivity, because metals react when they're able to drop electrons, and metals are more able to drop their electrons as you go down and to the left. Nonmetals, they become more reactive defined by their electronegativity, and fluorine is the most electronegative element on the periodic table.